Okay, MCP, the acronym that's sort of buzzing on the internet nowadays. I wouldn't say it's the most searched word on the internet nowadays, but it's certainly one of the most searched acronym on the internet. So today I'm gonna spend the next couple minutes, if not 40 minutes, reading the MCP specification, which is suggested and proposed, written by one of the most prominent company in the field of artificial intelligence, the company named Anthropic, who wrote and, if not invent, the protocol MCP. MCP stands for Model Context Protocol. It's an open source protocol that pretty much enables the large language model to do something. Instead of just giving a response to your question, they can also do something. Now, without further ado, let's go ahead and so the model context protocol is an open protocol that enables seamless integration between LLM application and external data sources and tools. Now, as you can see, we have data sources and tools. And sources can be files, your database, your image, whatever they can be as sources. And tools can be anything that can do something, right? We have a wrench, we have a screwdriver. These are tools, right? Tools are meant to do something. Now, to put it in context, imagine you are, let's say you are an investor and you got some investments online, as most of us or the majority of Americans today, they have some brokerage accounts where they trade or, they go lose money. Yeah, we all lose money on that. Or let's say you are sleeping at 4 a.m. and one of your friends just texts you. Imagine your name is John, and they just text you, "Hey John, did you hear what's happening in the Middle East now?" Let's say it's October 7th at 4 a.m. and you are in the United States. And John texts you, your friend Peter texts you, "Hey John, this is what's happening. Hamas has invaded, Israel. And I'm guessing in the morning the stock markets might stumble, right? Something may happen." Now, instead of waking up at 4 a.m., leave your bed, which gonna cause you a lot of problem. Instead of leaving your bed, go to your office to make a trade at 4 a.m. What if you can just tell your brokerage account or your Google or Siri, say, "Hey Siri, tell me what's going on the future markets." Siri will say, or Siri may respond something like, what do you want to know on the future market? Say, "Okay, tell me about the crude oil. What's happening with the crude oil?" Siri may respond something like, "Oh, I see everything look right. It's 2% up," right? And then you ask another question. "What about the analytic? Tell me about the analytic of crude oil." And six, we say, "Oh, I see the moving average is crossing the exponential moving average," right? These are indicators, some statistic indicators. And then you know that's when the moving average, the general or moving average is crossing the exponential moving average. You know that something is about to happen. You know that the crude oil will explode in a couple of minutes. And then you still on your bed, you just tell Siri, "Hey Siri, use 2% of my accounts and buy me 10 contracts on the crude oil." Boom. Now let's continue. Whether you're building an AI-powered IDE, the IDE is the integrated development environment like a Visual Studio or PyCharm or WebStorm, or you are enhancing a chat interface, right? Any chat interface, or creating a custom AI workflow. MCP provide a standardized way to connect LLMs with the context they need. And as in my previous example, I was saying like the context of trading with your voice, which may be possible in the couple years coming, maybe in 2027, if not 2026. We may be able to trade with our voice at 4 a.m. Who knows? MCP provide a standardized way to connect LLMs with the context they need. LLM means you give instruction with your voice or you give instruction with your text, and the AI will go ahead and do something using your instructions. This specification defines the authoritative protocol requirements based on the TypeScript schema in schema.ts, right? And then we can see the TypeScript schema. This is the schema that details the way data will be transferred between client, the server, and the data of the type. Of course, the JSON RPC, which will be the protocol that we use data transfer between a server and a client. Okay, and then as in any specification, they have to specify these keywords. We have must not, require, shall not. These are the keywords that are recommended according to this best current practice of writing a specification, RFC 2119 and the RFC 8174. Now let's go to the overview. MCP provide a standardized way for application to share contextual information with language models. By contextual information, we mean in the case of investors, you can trade with your voice, you can trade with text instead of leaving your bed at 4 a.m. In the context of managing the temperature of your room when you are out at work, you don't have to use your phone at work. You may get in trouble. You can just speak to LLM. What is the temperature in my room at home? The LLM will tell you this is the temperature, and tell the LLM, hey, go ahead, reduce the temperature or turn off, the thermostat. And then the LLM will automatically turn off your thermostat. Expose tool and capability to AI systems and tools by doing something, acting, Instead of the LLM to retrieve text, they can do something. Build composable integration and workflows. By composable integration, we may do something like automatically deploying application or putting all the tools together. There are tools that send the email, there are tools that writes emails. Let's say your friend John will be having a wedding next month or in a few weeks, and you can ask your phone, hey Siri, tell me about my calendar. And then Siri will respond something like oh, okay. And then Siri will respond, on July XYZ, John will be having his wedding. And you can say, would you write a polite email declining invitation to John's wedding? Siri can do that, or Google can do that for you. And this is where the integration, building composable integration and AI for. So you're using all the tools together to do something. The protocol uses JSON RPC. The JSON RPC is a format, is a protocol for transferring data between a client and server. So yeah, they use the protocol they use JSON RPC. If you need more about JSON RPC, I'll put a link on the description so you can go read about JSON RPC. And to establish the communication between the host, right? The host is where the clients will be reside. The clients, of course, the host is basically the machine where the clients will be reside. And the server are services that provide context and capabilities. MCP takes some inspiration from the language server protocol. The language server protocols is the architecture that Microsoft use for creating extension that can be integrated in your Visual Studio Code, right? Let's say you create an extension that enables you to write a Python code, or you customize any extension. This architecture between using a client and a server and send the data between them using JSON RPC, this is the architecture that the MCP is using. Who knows, they may change that in the future, but as of now, this is the inspiration of the architecture they're using, which standardize how to end support for programming language across a whole ecosystem of development tools, right? In a similar way, MCP standardize how to integrate additional context and tools into the ecosystem of AI applications. Now, let's go to key details. They use the RPC message formats. They use stateful connections. Stateful connections, when something is stateful, it means persistent. 7 clients capability negotiation. By 7 clients capability negotiation, that means that the server automatically propagates or expose to the clients what are some of the tools that it has, So the client doesn't need to necessarily to ask the server, hey, what do you have, like tools? The negotiation happened right before the server and clients start communicating. There should be some negotiation, like in the case of TCP. So for those of you that know how TCP, the transport layer on TCP stack works, is that before sending even data, there is a end check that these are the negotiation. Features. Servers offer any of the following features to clients. Resources. By resources, your server will offer things like, data, pictures, database, prompts. Prompts are templates, So you may define your own template if you have a specific tool that you're going to use. You may define your own template. Tools are any executable or any endpoints that will do something for you. Clients may offer the following feature to the server. Sampling. Samplings refers to the ability for a client to have its samples of instruction or prompts that will be sending to the LLM or your model. Server initiates agentic behaviors and recursive LLM interaction. Okay, now let's go to additional utility. We have the configuration, the ability to configure your connection between the server and clients, process tracking, cancellation, error reporting. You can report the error if something, let's say in case of authentication, if something happens, or if you launch your clients, they can connect to the server. You can also do error reporting, like your loggings or the error on the logs file. And of course, they have logging. Security and trust and safety. The model context protocol enables powerful capabilities through arbitrary data access and code execution path. Within this power comes important security and trust considerations that all implementers must carefully address. Right. So these are some key security consideration or recommendation if you want to implement this protocol, and the following some recommendation. User consent and control. Okay, key principle number 1. User must explicitly consent to and understand all data access and operations. User must retain control over what data is shared and what actions are taken. Right? Implementers should provide clear user interface for viewing and authorizing activities. And these are, some security recommendation, like when the user are using your agents that integrates, tools that enable the user to not only retrieve some text but do something. You have to make sure that the user consents and understand data access, right? Data privacy. Host must obtain explicit user consent before exposing user data to servers, and this in case of OAuth authentication. Let's say you want a user to authenticate to Google before using your agent or your application. These are some data privacy. We all know about this data privacy. I'm gonna go ahead on the tool safety. Tools safety. Tools represent arbitrary code execution and must be treated with appropriate caution, right? So just make sure you don't expose any tool that will cause harm. In particular, description of tool behavior such as annotation should be considered untrusted unless obtained from a trusted server. Host must obtain explicit user consent before invoking any tools. Users should understand what each tool does before authorizing its use. So you don't have to create an agent or an application that let the user give you authorization via Google or via any third party or auth authorization, and then you're gonna go grab their files and then push it on your remote server. That's illegal. That's why you see all these particular statements are under tool safety. LLM sampling control. So on the LLM sampling, it means just you can define your own prompts that will be sending to the LLM so it can understand the context. User must explicitly approve any LLM sampling, right? Don't create a sample list like that will be untrusted by the user. Things like go kill somebody, all this illegal sampling, right? Users should control where the sampling occurs at all, right? So the user that will be using your application, they have to know about the samplings. You have to inform them about your sampling. If you're using samplings, samplings are just templates, a set of templates or prompts that you're going to send to your user, or you're going to predefine in your application that users should know. In the case of my example, where I say like Siri, tell me about the future market at 4 a.m. This sampling, the user, they have to know about that. Implementation guideline. While MCP itself cannot enforce these security principles at the protocol level, implementers should, number 1, build robust consents and authorization flows into the application. Right? If you're deploying something for the public use or for your customers, make sure the customer is aware about the authorization or the third party or auth authorization. Provide clear documentation of security implications, right? Inform the user. If you're deploying a tool that the security is not guaranteed, inform your users. Implement appropriate access controls and data protection. Protect user data. Follow security best practice in the integrations. The RFC 11, I think the RFC 9700, right? 9700 is the RFC that tackled best security practice in the integration. Consider privacy implication in the feature design. So if you create tools that have some features, make sure that the privacy of the user are respected. Now, this is just the starting points, but I'm gonna go on the one that interests me the most is authorization. Let's go on the authorization. Okay, authorization, introduction, purpose and scope. The model context protocol provides authorization capabilities at the transport level. So the authorization is happening at the transport level, enabling MCP clients to make requests to restricted MCP servers on behalf of resource owners. Right? So every time you hear about on behalf of, it's either you're going to implement the OAuth authorization, which include authentication and authorization, or you're going to use the OpenID Connect authorization method, which has similar features, right, with different implementation. Protocol requirements. Authorization is optional for MCP implementation when supported. Authentication and authorization are two different terms, or if I have to use concept, I have to explain. Authorization and authentication are two different concepts. By authorization being optional in this case is that you may authenticate the user, but you may not do the authorization. By authorization, you are restricting a certain part of your application or your tool to be used, so it's optional. Of course, in any application, authorization, well, it depends. In the context of this specification, authorization is optional, right? But when you're building your own application, your REST API or whatever, your data, mostly your database, cool. Let's continue. Implementation using a HTTP-based transport should conform to these specifications. So if you are implementing this protocol using HTTP, you have to conform with the HTTP. Implementation using a standard IO transport should not follow this specification and instead retrieve credentials from the environment. So this means that if you are implementing this specification and the transport and your transport is a standard IO, by standard IO we are referring to your sockets, you should not follow this specification because the credential should be used via the environment variable. Implementation using alternative transports must follow established security best practices for the protocol. So the protocol also gives you the ability to use alternative transports, like the HTTP, of course, the HTTP to standard compliance. This authorization mechanism is based on established specification list below, but implements a selected subset of the feature to ensure security and interoperability while maintaining simplicity. Right? We have the OAuth 2.1 ITF draft. So the OAuth 2.1, it's still in draft, right? It's just a best practice of the OAuth 2.0, right? These are the standard compliance they'll be using on the authorization right here. They also use the OAuth 2.0 dynamic client registration protocol. You can go ahead and read those two RFC, the RFC 8414 and the RFC 7591. Now let's go to authorization flow overview. MCP auth implementations must implement OAuth 2.1. And when you hear OAuth 2.1, don't freak out. It just means that it means just any best practice recommended after OAuth 2.0 is the draft of OAuth 2.1, right? with appropriate security measure for both confidential and public clients. And the most prominent security measure you need to implement when using OAuth 2.1 is that you need to use the PXE, which generates the client's token, so you cannot lose the authorization from the identity provider. If you know, you know. The MCP auth implementation should support the OAuth 2.0 dynamic client registration protocol. And this is the RFC. You can go and read that. The MC server should and MCP client must implement OAuth 2 authorization server metadata. The RFC 8414 server that do not support authorization server metadata must follow the default URL schema. And the default URL schema is when, as soon as the authorization is granted, the URL that gives you authorization will retain the schema that will allow the user to get the token, to get the key, and so forth. Point 21.1, auth grant types. OAuth specifies different flows and grant types, which are different ways of obtaining access token. Each of these targets different use cases and scenario. MCP server should support the OAuth grant types that best align with the intended audience. For instance, authorization code, useful when the client is acting on behalf of a human or end user. In this case, when you're using JSON web tokens or using a token, basically a token that is sealed via authentication. Use a password and use a username, you seal that, and then you create a token. For instance, the agent called the MCP tool implemented by a SaaS system. So if you have your agents that need to use a server and accessing that server require authentication and authorization, you can use a token to allow the user, send the username and password to get a token, and then they can access the tool. Client's credential, the client is another application, not a human, right? For instance, the agent call a secure MCP tool to check inventory at a specific store, no need to impersonate the end user. Okay. Authorization code grants. This demonstrates the OAuth 2.1 flow for the authorization code grant type used for user auth. And the next step we explain the implementation, the best recommendation of using OAuth 2.1. The following example assume the MCP server is also functioning as the authorization server. However, the authorization server may be deployed as its own distinct service. So there is a different way you can use the authorization server. It's either your server itself is the authorization and the authentication server, or your server has to allow the user to get the authentication and redirect back to itself. Okay. Note the following example assume the MCP server is also functioning as the authorization server, but the authorization server means that the user has to send the token to the server before executing a task. However, the authorization server may be deployed as its own distinct server. You may also have the authentication server and the authorization server. A human user completes the auth flow through a web browser. So they're recommending a human to execute the auth flow. I don't know if a machine can do that. It's possible, but a human user has to complete the auth flow. Obtaining an access token that identifies them personally and allow the client to act on their behalf. And that's OAuth 1.0, 2.0, which means if let's say you have your tools behind agent, right? And you want your user to authenticate. Before your user authenticates using your tool, they have to go give authorization via Google or the integration of Microsoft or Auth, meaning that your user first need to be authenticated to a Microsoft server and then send the token back to your authorization or server before doing anything. Okay. Let's continue. When authorization is required and not yet proven by the client, servers must respond with HTTP 401 unauthorized. We all know that, meaning that even if you have your tool behind your agents or your tool within your agents, if the user is not authorized, they should get a 401 unauthorized. We know that. Clients initiate the OAuth 2.1 IEF draft authorization flow after receiving the HTTP 4.1 unauthorized, right? If the clients want to implement the OAuth 2.1 and they go ahead on the Google, the access was now accepted, they should get the 401 unauthorized. The following demonstrates the basic or OAuth 2.1 for public clients using Pixie. And you heard about me talking about Pixie. Pixie, which is the ability of the clients to create a challenge code, and that challenge code will protect a loss of the authorization token from the ID provider, from the identification provided. Let's say your user, right? Let's say your user wanna authenticate to your server, and now you're implementing the OAuth, right? You want your user to authenticate first to Google, allowing Google to use that server to use that server, and then authenticate to your server. So if the user authenticate to Google allow them to go use your server, they may lose the token between authenticating to Google and sending and redirecting back to your server. And by server, I'm referring to your MCP server that will execute some actions. Now, they may lose that token in the way, but with Pixie, when they're using Pixie generates a challenge code on the clients. So as soon as the clients click on authenticate via Google, the OAuth automatically creates a key, a challenge code. It saves it on the client side and it redirects to the identity provider, which is Google. And then they give access. And when they give access, when they're sending the code back, both the authorization server, which can be your tool, and the identity provider, which can be Google, they know about that key, so nobody can steal the token between the clients and the server. As you can see, they're detailing that right here on they're detailing all the steps right here on this sequence diagram. Is that sequence diagram? I think it's a sequence diagram. So first we start with the clients. The client send the request to the server, the MCP server. The MCP server say, hey, you are unauthorized to use my actions or my resources. It's sent back to a response, and the clients go to the browser. They open the browser, and you can see there is a code challenge right here. Right here, we have a code challenge. So this code challenge, I didn't explain the Pixie. Pixie stands for proof key for code exchange, right? Proof key. So the proof key is this key that is generated on the client side. So the client side gets the URL authorization, and then it also generates the code challenge, and then it sends the code challenge to the MCP server. The MCP server redirects the clients to the identity provider, if not to the server from which the client has to authorize authentication. Redirects back to the URL with auth code, right? And then the user call back with authorization code, and then it send the token request with the code and the code verifier to the server, right? And what's happening here, the user may go back to, the user may go back to its identity provider, like Google, or by identity provider, I just means that I'm referring to any third party or auth that will allow the clients to authenticate to that particular MCP server, right? So bear in mind, if there is something you need to retain right here, is that the user does not need only its password and username to grant permission to the MCP server, but the user also need to generate a challenge code that will protect the token from the identity provider Google to the server that authenticates or authorizes the user. And then when the authorizations go back, when they call back with authorization code is sent to the clients, of course the clients, and the client send that to the MCP server. And what's happening right here, what's happening here, it's either the client itself or the client is authorizing via Google authorization or Microsoft or any third party or authorization. And then the server will issue the access token plus the refresh token. And yes, and then the MCP request with the access token, and then the user get the access token for the next request. Oof, that was a lot. But it's simple. It's pretty much the API is still following you behind the scene here. If you know how to use the REST API, or the SAML, or the security assertion markup language format, if you know how to use REST API, you know what's happening behind the scene here. But they are recommending they're recommending using the OAuth 2.1. Server metadata discovery. The client discover that in anything that's successful when the user authenticates, the response is okay plus metadata documents. And if it fails, they have to say not found, right? This is the fallback URL. Authorization-based URL. The authorization-based URL must be determined from the MCP server URL by discarding any existing path component. For example, if the MCP server URL is HTTP API https:/api.example.com/v1.mcp, then right, I mean, what's happening, they're just explaining the context from which authorization has to, or the authorization based URL has to happen. The authorization based URL will be, of course, the domain, or the fully, this one we don't call that domain, this one we call that the fully qualified domain name. Why? Because this is the domain name and this is the fully qualified domain name, which include the subdomain and the root domain. The metadata endpoint must be, this is the metadata endpoint, must be API example.com well-known auth authorization server. This is where the response will be the URL for authentication, the URL for generating a token, the URL for generating, let's say, key, and everything that will allow authorization. This ensures authorization endpoints are consistently located at the root level of the domain hosting the MCP server, right? So this endpoint, this one, it's not the server from which you are going to send your tokens. This is just the metadata endpoint. It's kind of like the API route that will expose the URL for authentication, the URL for generating a token, and all relative URL. Fallbacks for servers without metadata discovery. For servers that do not implement OAuth 2.0 authorization server metadata, clients must use the following default endpoint path relative to the authorization-based URL as defined in section 2.3.2. Now, not all of us will use the OAuth authentication method to authenticate and authorize user before using the tools. Some of us will still use the default simple token, which is signed by using the password and the username, right? So in that case, the MCP recommend using the authorized endpoints used for authorization, the token endpoint used for token exchange and refresh, and the register used for registering, let's say, your username and password. So the user will register right here. Once they register, they will get the token right here, and they will be authorized to access resource on authorized endpoints. And all these endpoints are explained as you can see. For example, with the MCP server hosted at the api.example.com/v1/MCP, the default endpoint will be authorized token registered, but it has to go first by register, get a token. When you register, you get a token, and you authorize. I think maybe they're confusing, but my understanding is just that you cannot authorize and then get a token. You need to authenticate, and authentication happens after registering. So it's gonna be first you have to register, you get a token, and you get authorization. Clients must first attempt to discover endpoints via the metadata documents before falling back to the default path. So the clients, your agent clients has to discover these metadata endpoints before allowing the user to do whatever, I mean, registering or logging. Register means may also means logging. I don't know about the register. This concept here, register, it's kind of like ambiguous. I don't know what they mean, but I'm assuming register means logging, if not registering, because the clients has to know about this, so they have to log in, right, before using the tool. Dynamic client registration. Okay, they're explaining registration. What's happening about registration? MCP clients and servers should support the OAuth dynamic client registration protocol to allow MCP client to obtain OAuth client's ID without using iteration. Oh, okay. So when you have your clients, before your clients, like as we see with clothes, right? Before starting to use clothes, you need to authenticate, and this authentication might be possible. It's usually possible using your username and password, or you can go to Google Authenticate and then start using Cloud. So this is what they're talking about, dynamic client registration. So before even launching your client has to authenticate using Auth 2.0. Okay. Now let's read the next paragraph. This provides a standardized way for clients to automatically register with the new servers, which is crucial for MCP because clients cannot know all possible servers in advance. Because our clients and the servers, they exchange information, metadata before start communicating, so the authentication has to be dynamic. Clients cannot know all possible servers in advance. Manual registration will create friction for user, so yeah, they don't have to register manually. So before even using the clients, they have to authenticate and give the server everything they need about authorization and token. It enables seamless connection to new servers, right? So when you have your clients and you have a bunch of servers, right? So if you add a new server, right, your client has to be able to automatically detect those new servers in your agent application. Server can implement their own registration policies. Okay. Any MC servers that do not support dynamic client registration need to provide alternative way to obtain a client's ID. And if applicable, client secrets for one of these servers. MCP clients will have to either hard code a client's ID, which is a bad idea. You don't have to hard code the client's ID. And if applicable, client secret specification for that MCP server, or presents a user interface to user that allows them to enter these details after registering a auth clients themselves, for example, through a configuration interface hosted by the server. And this is what I was saying, just when you create your client's agent, make sure that before the users are using that, they need to authenticate when you are using OAuth authorization. But not all clients application, they have to use a OAuth 2.0 authentication or authorization method. Now let's go to authorization flow step. And this is authorization, right? Does it include authentication? They're not talking about authentication. They're just talking about authorization. Maybe they imply authentication is included in authorization. But these are two different concepts, authentication and authorization. I mean, they're referring, the clients has to authorize the authentication before start using the MCP server. Now let's go through different steps on authorization flow. We have the clients get the well-known auth authorization server. So the well-known auth authorization server right here, this is not the URL where the client has to send his token. No, the clients will not send their token in this well-known authorization server. The clients will use this well-known as a metadata, as a URL, as an authorization-based URL, right? It's a base URL that is exposed within different URL. The URL for authorization, the URL for getting a token, the URL for registration. The server supports discovery, authorization server metadata. When there is no discovery, of course, the gate's not found, which means the well-known does not exist. Dynamic client registration, if it exists, if this base URL exists, the clients register. I think this is just a a summarized explanation between the client and servers. Let's go on the next step. The clients open the browser and they generate a code, and the code is via Pixie, proof or key call for code exchange. The client send the request. What's happening here? It might be via Google. The client sends the authorization request to the server. The server requests back with the code, and the client sends the token to the server with the code verifier. And what else? And the server responds with the token and the refresh token for the next refresh if the token expires. And the clients are sending API requests with the token. It might seem intimidating, but you need to know how basic authentication works and how the OAuth authorization authentication works as well. And this is a decision flow. We have a start flow, auth flow, check metadata discovery. Metadata discovery is just a API rule of the API roots endpoints. In this case, we have the well-known authorization server. This will be the roots endpoint that we expose the endpoint for registering, the endpoints for authorizing, the endpoint for getting the token, and all this bunch of endpoints. If it's available, we continue. If it's not available, they get 404 not found, 404. I don't like using 404. It's not O, it's 0. They check the registration endpoints, and the registration endpoints will be retrieved from the well-known authorization server. They perform the dynamic registration. Yeah, I think hard coding, user credential, hard coding, user ID, it's not recommended. I don't like that. I think using Google or authorization server will be the choice. Google authorization server or using a Microsoft authorization server. I mean, hard coding, I don't think it would be the best idea to do that. User register. What else? Once they register, if it's not required, it's gonna be no registration. They just go to start auth flow, or they perform dynamic registration. They generate a Pixie parameters. A Pixie is just a challenge code. They request authorization. So registration means using the username and password to register, because I was confusing the registration in terms of register to login or register to create an account. So registration is the dynamic registration, which means create a username and password. So the authentication is happening right here. They generate a Pixie key, a challenge code. They request authorization via Google. The authorization is grants. They send that to the server, and the server exchange code and the tokens, and the client use the access token to use the API. And this is the access token usage. This is the way you can use access token. We all know how to use that on the authorization header. I usually don't use the default bearer, because if you don't know how to configure your server well, and you don't use the automatic HTTPS configuration, should I say, you can expose your token. There is a possibility for you to expose your token, and there are some bots out there on the internet. They're looking for the word bearer, right? So as long as they're looking for the word bearer, you don't have to use your token bearer. You can change the implementation, avoiding the bearer words. Use any other word. And then this is the explaining the way you can use your token, so you can use your resource in your server. And they have a security consideration. The following security requirements must be implemented. The clients must securely store token following OAuth best practices. So if you're using a browser, putting on cookies or putting somewhere that can be secure so that nobody can, steal it. I mean, putting down the cookies much secure than local storage. I'm not sure, I mean, local storage is also secure, but if you don't use a content security post policy, anybody can steal that from your local storage via cross-site request forgery. Server should enforce token expiration and rotation. We know that. All authorization endpoint must be saved over HTTPS. You have to use the HTS configuration. Is that HTS? Okay. Is the HST configuration the street? Yeah, this one. Street transport security. So you have to make sure that your server, so you have to make sure that your server uses strict HTTPS, to avoid man-in-the-middle attacks. This is what I was referring to, which means if you're not using the street transport security measure, or the man-in-the-middle attack, within a few seconds they can catch your bearer. They'll be looking for the word bearer on the authorization, and they'll grab that. Also, when you're sending your access token in your server implementation, you have to make sure that they will just get the access token directly. You can also protect your access token by adding some salt. These are some possibilities, right, to avoid somebody to just steal it and send it. Okay, token handling. Resource server must validate access token as described in section 512. You have to validate token. Don't just send the token and then bypass that. That's what I used to do, back in the day. But I didn't know that. But hey, it is what it is. Server must validate redirect URI to prevent open redirect vulnerabilities. You have to validate URL. A URL is a URL with identification number. So validate that with authentication and tokens. Redirect URI must be either local host URLs or HTTPS URLs. That's about it. I can continue over and over reading on this documentation, but I wanted to spend some time on reading about this authorization specification, the MCP, because it's one thing about getting excited about technology or a new protocol, but it's also another thing about knowing how to effectively and securely implement that to avoid, any misconfiguration which will lead to losing data or allowing hackers to access your resource and do something on your tools. So I thought it would be better for me to read this. The document is written in English, and English is just a language, right? If you can understand concepts and know how to implement stuff, you'll be good to go. Okay, that about it. I'm gonna put all the link on the description if you want to read more about this specification. Go ahead and read it, and if you can send them an angry email, blame them about something that they should read, that they should have written a better way, send them an email. Yeah, that's all for today. Thank you for watching, and I'll see you in the next one.